Hi, thank you for joining today. My name is Manish, and I'm one of the founders of Yuvoh Analytics. We are a big data and machine learning company and provide property and rental estimates. In 2019, we valued up 20 billion euros of collateral. We have assisted clients in both the performing and non-performing loan space. In this presentation, you will get an introduction to big data and machine learning, an NPL case study with problems and solutions, and a client delivery example. One important distinction to make right from the start is that machine learning couldn't really exist without big data. When we talk about big data, we're talking about the enormous volume, variety, and velocity of data being produced by entities and individuals every single day. Big data analytics is simply the process by which we collect, manage, and analyze this large volume of both structured and unstructured data. The aim of this process is to discover patterns that can inform business decisions and strategies. To that end, we can summarize big data analytics as follows. It is to extract, store, and analyze vast data sets targeting a particular product or service. The purpose of big data is to analyze data efficiently and find patterns that will help stakeholders make informed business decisions. If big data describes all the information at our disposal, machine learning describes a particular way to analyze this data. Machine learning is a field of artificial intelligence. It's a process by which software algorithms learn to increase the accuracy for a targeted outcome. Machine learning algorithms are in use in everyday applications. For example, when booking a taxi via an app, the machine learning model will be optimizing for pricing, driver and passenger matching, and wait time minimizations. In other words, machine learning describes how programs teach themselves to become better at their jobs. How is this done? The simple answer is exposure to high volumes of relevant data through good model training. If you simply had real estate portal data, then this limits your variable inputs. If, however, you had sales prices, hotel booking data, how far a property is from a train station, and much, much more, then machine learning algorithms have much more data to learn and improve on. The bigger and more varied the data set, the more accurate our predictions will become. As you've already started to gather, the more data you have, i.e. big data, the more accurate the machine learning regressions can become. There are several problems in the current NPL valuation process. Banks will have originated mortgages 5, 10, or 20 years ago. As part of a data room, a buyer could receive a handful of grainy scanned-in copies of the original valuations. As a buyer, you will receive loan data tapes which will extrapolate based on some indexation, possibly even a bank indexation. A buyer would question the accuracy of this indexation and how it was constructed, leading to lower buyer confidence. The second problem is that physical and desktop valuations are costly and not scalable due to the human resources required, especially on granular loan data tapes. In some jurisdictions, simplistic comparable models exist, but later on in the presentation, we'll highlight some of the issues comparable models face. Depending on the territory and the strategy, a buyer may be required to take possession of the assets and sweat them out. In this instance, knowing what the long-term or holiday let rental returns could become very important, especially on a residential style portfolio. Finally, during pandemics like COVID, physical valuations are simply not feasible. The current NPL process needs to embrace technology to bridge the bid-ask gap, as well as to increase the efficiency within the process. The solution to improve the current approach is building a data catalog based on what we believe could drive house prices and rental cash flows. Our data sets are vastly bigger than what is highlighted, but I'll go over a few examples to show you the data relevance. Firstly, we need to assess the for sale properties found on property portals. You will therefore need to extract information from the most popular real estate portals in a particular jurisdiction. Similarly, we'll do the same for lettings. We then look to tie this in with property sales databases to help gauge the bid-ask as well as liquidity by regional area. We also look at geospatial features like how far a property is from the airport, the train station, and many other points of interest. We also have global datasets for short-term and holiday let style portals like Airbnb, which alongside normal rentals can be very valuable in driving prices as well as REO strategies. In economies like Greece, a rental strategy is important as the liquidity is simply not available to sell repossessed properties en masse. In the bottom left corner, you can see the current NPL valuation process. Grainy PDFs, a small subset of drive-bys, and Excel or CSV-based output. In the top right is where we are pushing the new process to be. Once a large and relevant data catalog is built up, then you can start to test and train the datasets to predict prices. The ultimate regression selection is based on finding the model with the lowest error rate. In Greece, we have tested many variations before selecting the best models. We also found that some areas like Athens perform very differently based on the variable inputs and require their own bespoke model to be created. Having a basic or fancy model is pointless unless you are improving the accuracy of the prediction. On the left-hand side, you can see a rank copula comparing the Yuvoh machine learning valuation to physical drive-bys in Greece. This was done on over 500 properties, and as you can see, there is a strong correlation between the physical valuations and the machine learning model. On the right-hand side, you can see a violin chart which shows the range and density of a Greek resi portfolio of circa 100 million euros. The middle green plot is the physical valuation. Assuming that the physical valuations are the most accurate valuation, then what you're looking for is the same plot and shape in any AVM model. On the left-hand side of that graph, and in red, you can see what the comparable model looks like. This doesn't look the same as the green plot. On the right-hand side and in blue, you can see the Yuvoh machine learning plot. The shape and density is much more aligned to the physical valuations. In this example, we found that the error rate in the comparable model was more than twice that of the machine learning model. Let me explain by way of an example. Assuming you have a two-bedroom property and there are 5 other two-bedroom properties ranging from 200 to 300,000 euros within 500 meters of your property. A simplistic comparable model would assume yours is 250,000 euros. A comparable model would not take into account that your property is on the beach and that the others are a few hundred meters away from the beach. A machine learning model using geospatial features like coastlines, etc., would be able to predict that your property is worth more. One thing to note is that for very high value assets, data availability is low, and a physical RICS approach may be a more appropriate solution. I hope the previous slides have explained some of the theoretical background. I would like to move on to a brief case study in Greece, including some of the problems and solutions. In this example, you have a bank in Greece looking to sell 20,000 residential and land assets in a relatively quick time frame. We have highlighted a handful of problems and solutions in the next few slides. The first problem was that the seller was using an internal bank index as part of the sales process. The bank index was not very believable, and when back-tested against physical valuations, the error rates was very large. The second problem was that there was no AVM solution by way of a comparable model, let alone a machine learning model, at the time that Yuvoh were approached. The solution was that we were mandated to provide an AVM solution. Within 3 months, we had built this. Not only were we able to build a comparable model solution, but we were also able to build a sophisticated and, more importantly, accurate machine learning model. The next problem. To value 20,000 resi line items with a physical or desktop valuation approach could take several months during normal times and create scalability and time issues. During a COVID environment, running a physical valuation approach is simply not possible. The fourth problem was a budgetary issue, as running a physical or desktop valuation on a large number of granular line items becomes very expensive. As mentioned, we were able to rapidly build a model to hit deadlines, as well as deliver a solution at a price point that is meaningfully inside that of a physical or desktop approach. The next problem is that Greece is a hospitality-led economy, yet data availability in this sector has been very poor. Finally, the liquidity for buyers to sell repossessed assets is simply not available. There are around 30,000 residential property sales a year, of which the majority are bank credit bids. However, resi NPLs coming into the market is estimated at a few 100,000. A buyer of NPLs in Greece needs to consider rental strategies to sweat out an asset, but this information was lacking. Yuvoh took a big data approach and over 2 years' worth of global holiday let rental data. We were able to provide an estimate on the holiday let rental income across Greece, as well as provide long-term rental solutions to help buyers consider alternative strategies. Additionally, Yuvoh have data on portals like TripAdvisor, helping to form views on a micro-hyper-local basis. This allows for gentrification indexes, as well as gleaning how many 5-star restaurants are within a predefined radius of your target asset. Once we gather the data and build models, Yuvoh have to provide a client delivery. We were able to provide an Excel-based output, but I want to highlight the 5-page PDFs we produced on each of the 20,000 line items as an alternative to a traditional RICS report. On the first page, you can see a deep executive summary slide. In the top image, you can see where the property is located, as well as an estimated asset value on the left. Just below this, you will see the confidence we have in that estimate. We're also able to break out statistics on a municipality or postcode level. The liquidity in the area is of importance to a buyer, especially in economies like Greece. We're able to showcase a variety of points of interest as well. We are able to provide density information based on our internal geoclustering technology. The auto-generated text on this property compares the asset to the rest of the area. The red lines are created to show where the asset sits compared to other variables in this region. On page 3, we're able to provide both the machine learning and comparable valuation. We can pin where the comparable properties sit compared to the target asset. We're also able to provide statistical and quartile-based information on the asset value. On the 4th page of the PDF, we're able to showcase rental yields, statistical data, and a large comparable table with numerous variables. On to page 5. In Southern Europe, having a short rental strategy could be valuable. We're able to provide an executive summary of what the property can earn, including occupancy and seasonality data, as seen in the top graphs. We have rental yields, quartile breakdowns, and a comparable table at the bottom half of the page. Knowing what this sector looked like pre-COVID could provide deeper insights on what the sector could look like in a post-vaccine world. The solutions we are providing are not to replace RICS valuers, but rather a complementary solution. In Greece and Cyprus, we have formed a partnership with a local RICS firm. This is helpful to us as we are able to get local knowledge insights, as well as constantly backtesting against physical valuations. For the RICS firm, this is a new service that can be sold to their existing client base. On the left-hand side, you can see that Yuvoh have real estate data across all of Europe. In several of these territories, we have built models and have backtested against physical valuations. We will continue to expand our RICS partnerships in the future. I hope you're able to see the value of big data and machine learning, and especially in the NPL sales process. Please email us if you'd like to discuss anything you've heard today. And thank you for taking the time to listen to this presentation, and I wish you a good day.